All right, let's kick off this explainer by immediately testing your mental spotlight. Before we dive into the fascinating and sometimes heavy science of how our brains age, I want you to do me a small favor. Try to anchor these 5 totally unrelated words in your mind for the rest of our time together. You ready? Here they are: velvet, compass, orchid, granite, echo. Try to really visualize them. Picture a piece of soft, crushed velvet, a heavy brass compass, a vibrant purple orchid, a rough piece of granite, and the distant, fading sound of an echo. We're going to come back to these at the very end, but here's the catch. No writing them down. Let them settle right there in your short-term memory as we keep moving. So you're here to understand the aging brain. Today, we're taking some incredibly dense neurobiology and translating it into a really fascinating look at how your brain actually changes over time. We'll be looking at the physical structures, think of that as your brain's hardware, and the adaptable, resilient networks that make up its software. Because, as you'll see, how your mind ages isn't just about the ticking of the clock. It is heavily influenced by the daily physiological choices we all make. To reduce our cognitive load today, here's our roadmap. 1. Aging versus cognitive decline. 2. Secrets of the superagers. 3. The brain-body connection. 4. Post-viral brain fog. And 5. Building cognitive reserve. Section 1. Aging versus cognitive decline. Let's start with the big question most of us have as we get older. What's just normal wear and tear, and what's an actual red flag? Let's break down the dividing lines. In normal aging, your autonomy is completely preserved. You might be a little slower to find that word that's right on the tip of your tongue, or maybe take an extra beat to recall a name. But interestingly enough, healthy older adults actually have larger vocabularies and a much deeper comprehension of word meanings. Then there's mild cognitive impairment, or MCI. This is kind of a transitional phase. Independence is still preserved, but there are measurable deficits, like constantly misplacing your keys or having noticeable lapses in judgment. Dementia, on the other hand, represents a profound loss of independence. We're talking about severe symptoms here, like spatial disorientation even in completely familiar environments. Now, the physical reality behind those normal, everyday changes is pretty staggering. As we age, our brain's hardware naturally shrinks, literally. Between the ages of 40 and 90, a typical brain loses about 100 to 120 grams of weight. That's roughly the weight of a small apple, just gone. This structural loss is heavily concentrated in the prefrontal cortex and the hippocampus, which happen to be the exact regions responsible for complex learning and consolidating memories. Your neuronal communication becomes less efficient, blood flow decreases. It's just a natural physical erosion over time. Section 2. Secrets of the superagers. Because, well, here is where the story gets really interesting. Not everyone's hardware ages at the exact same rate. Enter the cognitive superagers. These are folks in their 80s, 90s, and sometimes even older, who just entirely defy typical age-related cognitive decline. Just imagine being in your late 80s, but having the crisp, sharp memory recall of someone in their 50s, 40s, or even a young adult. It's incredible. Researchers at places like Northwestern and Boston University are actively studying these people to figure out what exactly makes their neurological hardware so uniquely resilient. Look at the stark difference in volume loss here. Normal older adults experience an average annual brain volume loss of roughly 2.24%. But superagers, they lose only 1.06%. That is less than half the annual brain volume loss compared to your average older adult. They are actively preserving their cortical thickness, especially in a region called the cingulate cortex. That's a part of the brain that integrates memory, attention, and motivation. And this resilience really comes down to their unique cellular makeup. Post-mortem analyses have revealed that superagers have an unusually high density of these things called von Economo neurons. These are specialized, spindle-shaped projection neurons that are heavily linked to social intelligence, intuitive decision-making, and incredibly rapid information transfer. Get this, superagers actually have a higher density of these specific neurons than people who are decades younger than them. No way, right? Section 3. The brain-body connection. Let's see how all of this translates into our everyday lives. Because hey, even if you weren't born with a genetic lottery ticket of a superager, your daily physical habits directly determine the health of your neurological hardware. This number absolutely blew my mind. An observational study funded by the NIA looked at nearly 3,000 older adults and found a massive 60% reduction in the risk of developing Alzheimer's disease. 60%! And that was just for those who strictly followed a specific set of 5 healthy lifestyle behaviors, compared to those who followed one or not. So what are those magical behaviors? They're probably things you've heard before, but they matter. Regular aerobic physical activity. Aim for about 150 minutes weekly. Not smoking. Limiting your alcohol intake. Sticking to a Mediterranean or mind diet that's packed with leafy greens and omega-3s. And finally, engaging in mentally stimulating activities. Why do these work so well? Well, because cardiovascular health is brain health. High blood pressure and uncontrolled blood sugar cause these silent microscopic strokes that literally starve your brain tissue of oxygen. On the flip side, aerobic exercise physically enlarges your hippocampus by triggering the release of a protective molecule called BDNF, and BDNF actively grows new memory neurons. Now, we absolutely cannot ignore sleep. During your deep, slow-wave sleep, your brain turns on its glymphatic system. You can think of the glymphatic system as a fleet of microscopic brain Roombas that fire up during your nightly deep clean. Cerebral spinal fluid literally flushes right through the interstitial spaces of your brain, washing out toxic beta-amyloid plaques and tau tangles. Chronic sleep deprivation, like sleeping less than 6 hours a night in your midlife, stops this essential process dead in its tracks. And that actually doubles your risk of developing Alzheimer's decades later. Section 4. Post-viral brain fog. Now, it's not just the passing of time that affects our cognition. We also have to look at modern systemic disruptors to our brain's chemistry. Things like post-acute viral syndromes. Some truly cutting-edge research out of the journal Cell unpacks the exact cause and effect cascade of long COVID brain fog. Let's trace the steps because it's fascinating. It starts with persistent viral reservoirs hiding out in your gut. This triggers a chronic immune response using interferons, which basically blocks your body from absorbing tryptophan from your diet. Now, tryptophan is absolutely essential for making serotonin, so your peripheral serotonin levels just plummet. Finally, this lack of serotonin silences the vagus nerve, and since that nerve communicates with the brain, it directly reduces activity in the hippocampus. Boom! That's what causes that profound memory impairment and mental fatigue. The good news? Researchers are now actively looking at treatments targeting this exact serotonin pathway to try and reverse the fog. Section 5. Building cognitive reserve. Finally, let's talk about some tangible solutions. How can we actively build our cognitive reserve? If the physical brain is the hardware we've been talking about, your cognitive reserve is the highly adaptable software that can actually bypass local damage. So here's the question. How does your hearing affect your memory? Sounds kind of like a trick question, right? But it's actually one of the most vital insights in modern neurology right now. Uncorrected sensory deficits are a major hidden risk factor for dementia. Here's the why behind it, known as the sensory cognitive load hypothesis. When your visual or auditory signals are degraded, say because you need glasses or a hearing aid but aren't wearing them, your brain has to work overtime. It's forced to shift valuable executive resources away from your temporal memory networks, specifically the hippocampus, just to decode those incoming muffled sounds or blurry sights. It steals your critical processing bandwidth. It leaves literally no power left to encode and store new memories. Correcting your hearing or vision instantly lifts that load. It's a remarkably simple fix for a huge problem. So, to buffer against physical decline, you have to actively maintain your reserve. First off, challenge your brain with true novelty. Doing the exact same daily crossword puzzle or playing your 500th game of Wordle, that doesn't really cut it anymore. You need to learn a new language, pick up a new instrument, or try navigating a totally new city. Make sure to correct any vision or hearing loss. Prioritize balance and aerobic exercise. Fuel your brain right. Research actually shows that adding just one daily serving of dark leafy vegetables significantly slows cognitive decline. And finally, review your medications with a doctor. You want to make sure you aren't accidentally taking hidden sedatives like certain everyday antihistamines that can actually mimic dementia symptoms. Which brings us right back full circle. To prove just how important your spotlight of attention is and how actively you have to engage your mental software, I've got a question for you. Without rewinding, can you recall those 5 words from our opening challenge? Think back for a second. Got 'em? They were velvet, compass, orchid, granite, and echo. If you remembered all of them, fantastic job. If you didn't, don't worry. It just shows how easily our mental bandwidth gets consumed by new information. The neuroplasticity of your brain isn't a fixed trait. It's a lifelong project. So what's one novel, challenging thing you can do today to start building your cognitive reserve for tomorrow? Think about it. Thanks so much for joining me on this explainer, and keep that mental spotlight bright.